everybody, this is a buzzword nowadays, that everybody is moving their applications into the containerization. So everyone know about this concept because this is a very, very good technology, or you can say the technique which is available in the market. But we should understand why we require such techniques. Correct? What is the container? Means what is actually there? Correct? This is another questions which you want to understand. What is the container? And I'm not talking about Docker at this moment of time. I'm just talking about the concept called as container. Correct? So we should understand what is exactly the container. And third concept is how it will work. There are two working methodology which I'm going to define it. Correct? The first method is a logical concept. And second one is a practical concept. So these are the two methods which we can use to understand how it will work. You can say it is a concept of Docker internal. So you can say like that. Correct? So why we required container? That is the first question. Now everybody, if you are coming from a software development background, nowadays whatever applications which we are using, 99% web application, correct? These web application, we already know that the design of the application is a 3-tier structure. Correct? We have a front end, we have back end, that is nothing but a business logic, and we have database. Correct? So this is a 3-tier architecture which we are using in order to design our application and run the entire environment of the application. That everybody knows. This is a very basic concept. Correct? But we used to design such application which with monolithic way, or you can say monolithic is the method which we were using to design such application. Correct? So understand, whenever any application, especially web-based application, if you want to design, and we know that the application do have 3 parts: front end part, business logic part, and a database. And if you start designing such an application with a monolithic style, now monolithic, if you try to find out the word, or if you go to the dictionary, then you need to understand monolithic means large.
Excuse me, Mangesh, there is some problem with the microphone. We are not able to hear you properly. It's sometime it's having some static or something is there. Can you check?
Okay, let me check. Can you check right now? Is it better?
Yes, Mangesh,
Yes.
it's perfect now.
Okay. So there might be some mic problem. That's fine. So understand, I'm sorry about that. Let's continue. So let's understand the monolithic method, or you can say I want to design an application with monolithic style. That means my entire application could be a large single block. Correct? You can imagine if I want to design an application for ERP. Now ERP do have a lot of modules which we are using. Correct? So if I say ERP is one of the application, if I want to design it in a monolithic style, So whatever modules which I want to develop in a ERP, it should be a single large block of the application. So it contains something like payroll, correct? Warehouse management. There are many things. HRMS, correct? So you can understand my normally old application, especially in a telecommunication industry nowadays, they are still using the application which was designed in a monolithic style. That means the entire application would be a single large block. So you can imagine what could be the size of the application. It's a huge. Plus, there are very limitations, or you can say there are a lot of limitations are applicable if I design any application in a monolithic style. First, very important limitation, that if I want to do the development of any single module, it is not technically that much easy. It was possible. I'm not saying it is impossible, but if I designed an application in a monolithic style, and if I have a multiple modules combined in a single large block, then development will be very slow. The modules freedom, that means if I want to upgrade a single module, it will be very difficult, correct? The manageability wise, yes, you have to handle a single block. So you can say, as an administrator, if I'm managing that particular application, it could be easy because that is a single block which I want to manage. But there are a lot of limitations are there. Development is not happen frequently. If I decided on any single technology, when I started this particular project, I have to stick with that particular technology till the time, correct? So this is the way we are using the applications, correct? Now, because of these limitations, we designed another way to handle all the development of the application, that we can call it as microservices, or you can say microservices, correct? Now, what is a microservice? Now, if you are a software developer, it would be very easy to understand because those people are developing this. Microservice means you are developing the application with a different style. Now, here, I do not want my application to be a single large block, correct? Here, what I will do, if I'm designing any ERP based application, correct, it should be as a service. That means I am dividing this particular applications into a smaller chunk. So I will have a payroll is completely a different module. Now this is a complete separate applications, you can say like that. You do have a warehouse is a complete different module, correct? You do have HRMS is a complete different module. Now I am developing the same ERP, but this time I'm using the development style as a microservice. So every module, correct, could be act like a service, and that service will be communicating with each other with the help of REST APIs. Correct. So understand, now the designing of the applications are changed. People want the technological freedom, and microservices are giving you that ability. Now here, if I want to only upgrade, or if you want to do some redevelopment of a single module, it is technically possible, and it will be much more easier than monolithic style, correct? My microservices, that means whatever number of microservices I can do it, no problem. I can divide the ERP in a smaller chunk as much as I can. There is no practically there is no such limit. But To handle such microservices, it could be difficult if you try to chop down that application in a very, very small chunk. Plus, these microservices are rather communicated with each other all the time. So network bandwidth, their communication, it could be a headache for you. So developers or who is developing any application, they will restrict. Practically, they will restrict, okay, these are the number of microservices which I want to use in my application. That number could be fixed because I know that I do have an ability to create the microservices as much small as I can, but that is not a good idea at the moment. Correct? So you can understand first the basic method which we were using, that was monolithic. Nowadays, the web-based application which we are developing, that is complete a microservices based application, and these microservices are able to exchange the information with the help of REST APIs. Correct? Then there is no single word I talk about container. Correct? Now the real thing will happen. Now, how to run this microservice? Or in a single thing, how to run applications which was developed in microservices. Let's say I do have 100 microservices and my entire ERP based application, I divided that application into 100 microservices. For front end side, it could be a single dashboard, that is a front end, but behind the scene, the business logic which I'm talking about, those are nothing but 100 microservices which I want to run. Now, in a simple understanding, I want to run 100 applications now. Earlier, I told you monolithic applications, it would be very easy because I need to manage a single huge block. That's it. Correct? So it could be very easy for me to manage a single block, but now the painful task will be coming into the picture. That is nothing but the number of microservices which I use is more than a single block now. It's 100 microservices, for example. In real life, it could be more than that. Correct? Plus, I need to provide a runtime environment for my microservices. Or you can say runtime method. Correct? Otherwise, how could that particular application will work? Correct? So in my particular PPT, I'm talking about the same thing over here. Talking about what are the advantages of monolithic and microservices based applications. What are the disadvantages which we are using in a monolithic style? What is the solution? The solution is nothing but divide that application into the smaller chunk, and that is nothing but the microservices which we are talking about. That is absolutely fine. There are benefits in the microservices. It would be very, very demanding method to develop any application, but there is one more problem. How you can provide runtime environment for this microservice? A microservice is typically a single application running. That's it. But I need a computing power for that. Correct? I need a disk for that. I need a RAM for that. Correct? I need a network IO for that. So, plus I need environmental softwares to run that particular microservice. Correct? So here is the challenge will happen. Now there are three major runtime environments. Correct? The first runtime environment we can talk about is a physical machine. Correct? Now in a physical machine, what we normally do, we will purchase a server, we will install the operating system on the top of it. Correct? We will install the necessary binaries, libraries which are required to run that particular application. So you can say prerequisites, correct? Then if you have, or if you want to run your application on the top of Tomcat, Nginx, or whatever application server you want to do it, you have to do it, no problem about that, correct? So, and after that, your application built, you need to have, that means a war file or jar file, whatever type of application you want to run it, run it. So this is a one-time simple solution which we have. Take a physical machine, install the operating system on the top of it, install the necessary library, binary, application server, configure that everything whatever you required as per your configuration, and put your application over there, start the service, your application will start, no doubt, correct? But I told you that I do have 100 microservices which I want to run. So will it be possible to run all 100 microservices on a single physical machine? Technically, yes, you can do that. If you have a very good physical machines, then you can do that, no problem. It's properly manageable. But what if that physical machine goes down? Correct? Your entire application will be going down. That is one more thing. Second thing, if I got all 100 microservices running on a single physical server, and all of a sudden that particular capacity of that server is going, means it is less, you can say it is more consumed and required, you required more power to that particular server because number of application requests which is coming from your users are too much. So you need to scale your particular application. So in physical server, do you think it is that much feasible to do that? It is, yes, it is scalable, no doubt about it, but it is not that much easy. You need to bought a new server, you have to install everything on the top of it, and you need to configure on every application configuration which is required, correct? And it could be possible. So it's not that much easy. So if I want to run my application with the help of physical server, technically speaking, yes, it is possible. However, high availability, fault tolerance, scalability, it would be a very challenging part, correct? That is not that much easy to handle. I cannot have 100 servers where I can put a single microservice running. That is possible. If you have a money, you can do that. What if a single microservice goes down? That will not hamper your application at all, but that service is down, and that is a crucial service. Then I need to have another backup server who can run that service for you, correct? So I don't think though physical servers, it could be a good choice for microservices, correct? You can use it, correct? Technically it's possible, but you cannot think that is the best solution at this moment, correct? Second solution which we have, okay, that will resolve some of the problems which we were using the physical server. The technique is called as virtualization. Now this will solve some problem, but overhead is same. The process is same. I will create here. I used to have a physical machine. In this case, I used to have a virtual machine, but it's a machine. So that is nothing but hardware is virtualized. But end of the day, I need to install operating system. I need to install the prerequisite. Then my application should be running over here. Then what is the benefit of this particular thing on the top of physical machine? Here, I can achieve the scalability very properly, high availability. Yes, I need to create the complete clone of that particular application, no doubt about that, correct? But technically speaking, I will get some relief. Rather using a physical server, I do have a virtualization option that could be a better choice, correct? But still, overhead is there. You have to create the entire virtual machine of your applications ready. You can imagine the size of the virtual machines could be very heavy task. These applications plus your operating system plus whatever prerequisite you want to install, the size is a different way. Actually, size is quite huge. But yes, it could be a better choice than the physical machines, no doubt about that. Correct? Then, if I tell you that you can run a machine, or you can say you can run your microservices in a such a way that that microservice, that means your only application plus whatever necessary binary library configuration required for that particular application, if I combined it in a logical box, correct? Don't you think it's a better option for me? Correct. So the third technique to run the microservices is called as containers. Now let me tell you, container is not a new technology at all. Correct. We were developing such kind of technique. Actually, this technique is completely designed and developed by Linux developers. Correct? So containers, I'm not talking about Docker at all. I'm talking about containers. Correct? So container is a technique which will be much more better way to run this particular application. Now people start getting confused that what you are saying actually. Okay, I will do this way to understand it a better. So if I say, if I want to run any container, what I required actually? Yes, I required a physical machine or virtual machine. It's up to you. Correct? Give me a machine. Correct? So this machine, can I install my microservices directly on a physical machine? Yes, I can do that. If this is a virtual machine, can I directly install or run my particular microservices on a virtual machine? Yes, I can do that. No doubt about it. However, I don't want to run my microservices in such fashion. What I will do, I will take a physical machine, no doubt about that. I will install the operating system. Now, typically speaking, the operating system is Linux. Correct? I tell you why. You will get answer why it is Linux. Let's say I install the operating system. Now you said, sir, this is the same way you're doing for your virtual machine and a physical machine. Yes, absolutely, no doubt about that. So I do have operating system installed. Then rather installing my microservices, what I will do, I will install an binary or an application that is handle my container. Now in our case, we used to install Docker. You will come to know that what is a Docker. Correct? So what I will do, I install the operating system. On the top of the operating system, I do have the Docker engine installed. So this is how it should look like. So this is my operating system layer. Okay, this is my OS. Okay. On the top of the OS, I'm going to install my Docker engine. Now, why I'm taking the Docker engine? Because I want to run my microservices inside a container. Correct? So here is my Docker engine, or you can say container engine. Now you can see my developer who is developing my microservice, what they will do, they will create a logical box with the help of the concept called as Docker. Now, Docker file is a very good concept. You will learn if you go for a detailed course how to write a Docker file, what are the ways to handle it. But what developer will do, developer will write a Docker file in a such a way that he will design a logical box of his microservice. That means that logical box contain what? That logical box contain application, means whatever application built which is done, plus necessary configuration if there is a configuration required, plus whatever library support which he required to run that application. That's it. What my particular developer will do, he will design a container, or you can say an image. In that image or in that logical box, I have only my application plus whatever necessary configuration which I required, plus whatever library prerequisite which needs to be configured, I do have. So what I will do, I will take that particular box and run it on my particular machine. Correct? So my application running inside this logical box. Correct? Now, according to theory, correct? This is theory says you have to install the operating system. That means my kernel is there. On the top of the operating system, I should have the logical engine, or you can say a Docker engine or a containerization engine should be there. On the top of that, you are going to run multiple container images, whatever you want. So I can run whatever number of container images I want, no doubt. Correct? If I want to run 100 containers on a single machine, yes, I can do that. No problem. 100 microservices I want to run, no problem. No issues. But every container is isolated. This is a beauty of containerization. Correct? Every container which you are running on the top of this physical machine, which is running a Linux operating system, every container is isolated. Every container thinks that I got a dedicated physical machine, I got a dedicated CPU, I got a dedicated RAM. Correct? So if I say, if I run any particular container in this particular fashion, the container, whichever, whatever containers I'm running, it's completely isolated from each other. They don't know what is happening, but practically I'm running thousands of container on a single machine. And what is container? Container is nothing but your microservices, whatever application code which you want to run in a build format, whatever necessary configuration files which I want, whatever prerequisite library, whatever prerequisite files binary which I want to run, you can do that. That's it. So you can think, if I want to run any application on the top of VMware, what should I require? I require physical machine, correct? Or a virtual machine. Virtual machine, I told you, virtual machine is just a hardware emulation. I need to top, or I need to install an operating system on the top. I need to install definitely prerequisite plus configuration, correct? And then my application. So if I want to run my application in a virtual machine format, then this is how it should work. So you can see the size of this particular application could be in some GBs, correct? If I want to run 100 microservices, then rather at least I need to create 100 different virtual machines. Now here, if you try to compare with this scenario, which is a containerization, here a single machine can run 100 microservices and every container will be thin, it is isolated. Now how this magic is happening? How that container can be thin, they're isolated. They're running in a single physical machine. Now this is the magic. This magic is done by Linux. So if you go to the PPT side, this is what I have discussed in my this particular slide. Where do run microservice? Correct. So I told you about the physical server. The physical server, yes, we were using it. Still, we are using this physical server in majority of companies act. Correct. So this is how we are using it till so far. Correct. But what is the problem here? Lot of cost is involved. I told you how many number of microservices you want to run. If you have a capacity, run that much physical machine plus whatever failovers you want to create that much physical machines, no doubt about that. Correct. But this is not a really good choice for that. The second option which I told you is a virtual machine. Yes, it is much more better than physical, but once again, I need to have a physical server. I need to install some VMware ESXi server sometime, KVM sometime. Correct. I need to have some virtualized operating system who can do the virtualization for me. Correct. But once again, this is a hardware virtualization there. I have to create a virtual hardware. That virtual hardware, I need to install the real operating system. So my operating system thinks it is working on a physical hardware, but that is virtual hardware. This is also a very good option to do that. Correct. But this is also not very much reliable for my country. So this is the third option which we have discussed. I got a physical machine. I will install the operating system on the top, but I will install one more layer on the top of it that is called as Docker engine, or you can say containerization engine. So I can run multiple applications right now. Correct? Now they are actually running on a single physical hardware. They are actually commonly shared the same kernel of the operating system. Correct? But I told you, every container thinks by himself that he got a dedicated physical hardware. He got a dedicated physical kernel, so logical kernel. Correct? So he himself thinks that I am running alone on my particular container. But practically speaking, it's not true. Correct? And this technique of isolation is designed and developed by Linux developers. Linux developer was trying to do the isolation from long time back. If you go and check the history, they want to do the isolation technique from 1979. Correct? So better way, if you can check, correct? If you can go and check the history, Linux was trying to do the process isolation. They want every process which is running on a single machine, it should be completely isolated. Whatever resources they required, you will get all the resources to that particular process, correct? And every process will be running in the isolation form. Now this is achieved with the help of a technique. There are three techniques are developed, or you can say three concepts are developed in a Linux developer. The first concept, I will talk about this. The first technique that developed, that is called as C groups. Okay. The second technique, they called it as namespaces. And third thing is union file system support. A bit confused. Now you got your first answer of your question, which we have discussed. Why we required containerization technique? Correct. The answer is very simple. Currently, the development is happening in a microservice style. I need a huge computing power. I need to provide runtime environments to the microservices. I do not just want to run microservices like that. I need to provide the scalability. Correct? Now the scalability is should be horizontal. I need to provide a fault tolerance. I need to provide a high availability. Now these two techniques or whatever features which are required, it cannot be done with the help of physical server. Slightly done with the help of VMware, but not fully. But these all features, whichever you require to have in a microservices, could be done with the container. So that's the reason why container techniques are developed, because of the microservices. This is the answer of your first question. How it works, I told you. It is how practically you're going to implement a containerization technique. It's very simple. You have to have some physical server, correct? Either you will get a physical server physically, or you will get one of the virtual machine with the help of virtualization technique, correct? End of the day, I required a common kernel. That means I required an operating system. I told you, especially Linux, correct? And after that, I will install the Docker engine on the top, correct? So this is the simple scenario which we are talking about. Now here, my application is running. For example, app A, it's running, my microservices is running. If I want any resource, to whom I should talk? I should talk to the Docker engine. He is the one who is going to make sure that whatever resources which is required by microservices, I should get those resources from my underlying kernel or operating system, correct? So containers, how they are working? Container is a logical box. Inside that logical box, I do have my microservice, necessary binary, library, prerequisite, whatever I required, plus whatever binary files are required. That's it. I don't require anything else. In that box, I just want to run that box on this type of runtime environment. My job is done. I can scale down, I can scale up. It's very easy. And you can say the size of the image will be very, very less, because it does not contain any overhead of your operating system. It does not contain any unnecessary binary at all. Correct? We will see it practically in our next session, how actually it's happened. But understand, the concept is very clear. This is the concept. Why I required to run the microservices? How should I run? This is the runtime environment. You have to provide it. It should work. No problem at all. Then people ask me, is it a replacement of virtualization? I said, no. This is not a replacement of virtualization technique at all. Some people say it's called as OS virtualization. Yes, you can say that, correct? But practically, the OS is not virtualized. Logically, it is virtualized. Correct? I will show you practically. You will get amazed when you see practically this is what you are talking about. Then how this particular thing works? This particular thing works with the help of these three techniques. Now these three techniques, I told you, designed and developed by Linux developers. I told you this is technique is not new. They were doing it from 1979. The Linux developer want to do the isolation of the process, correct? So isolation of the process is done with the help of C groups, namespace, and union file system support. Now in our course, actually, we will go into the Docker internals, that how these three things will help us to do the process isolation, correct? But I will tell you in a small, in a very broader way, C group will handle the resource management. For example, your CPU, your memory, your network IO, correct? So all these things means whatever resources which you require, C groups will do the isolation for them, correct? Namespace. Now every particular machine do have a kernel name, you do have a process ID, correct? You should have a network related information, mount related information, correct? So if I would like to do the isolation of these all tasks, then namespace is a technique who can do the isolation of. Now people will get confused. We are not Linux savvy. Then what is this actually? Okay, let's understand how these things are. Linux developer develop their kernel, means the kernel version number 3.0 onwards. Okay. What they have done, they have make sure that these all three features will be supported by this particular kernel. Correct? So C group, namespace, and UFS support. Now earlier they do not have a UFS support, union file support. After that, we do have a device mapper overlay. ZFS do have an ability to do that, but currently we will not take that particular point in our discussion. Right? So only thing what they have done actually in kernel 3.1 means this is the kernel which is developed by this the Linux kernel 3.0 is developed in a such a way that any process which is executed on the top of it, this complete process is isolated. This complete process, I told you, this is how our container actually take the benefit of. So by default, these features like C group and namespace is already available in a kernel 3.0. Every process running on the top of this kernel, this process, let's say this is a process number P1, for example. Correct? This process will get all the resources in an isolated format with the help of C groups. I will show you practically how it works. So whatever this process is required, RAM, CPU, RAM, network IO, disk IO, whatever activity means hardware related resources, okay, computing related resources, whatever he required, every process do have its complete different C group in a hierarchical model, which will handle by that particular process only. So whatever processes which are running, every process do have its own resource group. That is possible. Correct? And that is possible with the help of the feature which is supported in a kernel 3.0 that is called as C group features. Now every process do have its own host name. That is also possible. Every process do have its own MNT, means mount point related information. Every process do have its own kernel related information. Correct? So what process can see, correct, that is controlled by, I will practically show you how what I'm talking about. Correct? This is kernel. Okay. So you can see these two feature is already available on the top of Linux kernel. Early days UFS support was not there, but after right now we do have a union file system support. Now why union file system support? What is overlay? What is a device mapper? We will discuss in a actually very detailed course what we require to understand. But currently you can see my Linux kernel itself do have a feature of isolation. Correct? So C group and namespace is two very beautiful feature developed by Linux developers to do the isolation of the process in terms of resource level, in terms of logical namespace and all other level. Now these feature is already available on the top of Linux kernel. That's why container technology is much more compatible to the Linux kernel. Now, when they develop these two features, actually the first product comes into the picture that is called as Linux containers. This technique helps us to run the process in an isolated format, the way Linux developer want. Correct? So understand the product which is called as Docker. Correct? Actually, Docker is built on LXC. Correct? What Docker is done? Now, Docker is the name of the product, name of the company. Docker want to take the advantage of this technique and try to start their own company who can help us to deploy your application. Correct? However, that particular plan was failed. And finally, he only used the same technique and launched the product called as Docker Containers. Now, what is Docker? Docker is just an abstraction layer to handle all these processes. Correct? Docker is taking the advantage of C groups, which is a feature of kernel. He's taking the advantage of the namespace. Correct? He's taking the advantage that your kernel is now supporting UFS. Actually, Docker is the abstraction engine who can run your containers in an isolated format. But practically speaking, that container is nothing but a single process. For Linux, it's a process, correct? Because whenever I execute anything, it's a process for my Linux. For Docker, you said practically what we do, we will execute a command, say Docker run Tomcat. Correct? This is a practical. What will happen? You will see a Tomcat container is running. Correct? But this is how Docker can tell you. But what about operating system? For operating system, this container is nothing but same like a process, which is running in what? Isolated format with the help of C group. Correct? Which is running with a namespace. That process will get its own everything. Correct? So this is what you need to understand when you learn about the containerization concept. Why we required it? How it is working? Simple. It's a container is nothing but a process for my operating system. How that particular process is running? Container can be controlled with the help of the Docker. Docker say start the container. Docker say stop the container. Docker say copy inside a container. But what is happening? End of the day, for my operating system, it's a process running in an isolation format with the help of the feature called as C group and namespace, which is supported by kernel version 3.0. So actually, Linux developer develop the concept of C groups, the concept of namespace, the concept of UFS to design and develop Linux containers. Docker actually took the advantage of this feature, create a beautiful abstraction layer, which will be very much easy to handle. You will handle every container with the help of a Docker, but end of the day, it's a single process running on your operating system in an isolated form. So every container which you are running with the help of Docker, it's a single process for my operating system, correct? And every process do have its own namespace. Every process do have its own C group, correct? So it's a completely isolated form. So this is how my particular container works. Now this is a complete theoretical. I said there are two different ways to handle it. So it's a logical format, correct? And it's a theory. This is how the logic of that particular application built. But practically, this is how it works, correct? So what we will do, we will take a break of 5 to 10 minutes. Then whatever we have discussed, okay, whatever we have discussed, I will show you practical in next 1 hour, correct? We will explain everything on the top of a Linux based machine. That will give you more idea that what I'm talking about. Container is running, but for the operating system level, it's something which we can call it as a process. Correct? So we will take a break of 10 minutes, okay, and we will start and continue doing practical. Okay, so have a cup of coffee or something. I will also grab a cup of coffee. Okay, just a moment. Okay, I'm back. So let me share you my screen. Now this is a Amazon machine, so which I'm using. I hope everybody is back. Okay, am I audible?
Yes. Yes.
That's great. I hope you are able to see the screen as well. Now, I will tell you one more interesting thing. I installed the Docker already on machine. So I told you that Docker comes with two different flavors. Docker C, that is nothing but a community edition, correct? And second one is called as Docker E, that is nothing but an enterprise edition. People ask me what is the functionality difference between these two. To be honest, the basic core functionality in both the cases are same, no doubt about it. Both the logical functionality is same, no doubt. The only Docker Enterprise Edition will give you the support, correct? And that is the add-on things which you can do it. Docker Enterprise Edition will give you some security enhancement which is done by the Docker internally. That particular support is also available over there. And that is a direct product is available, means direct security enhancement is already configured and designed in that engine. Same thing can be possible in a Docker community based edition as well, but you have to configure it. It's not by default configured. The licensing method for Docker Enterprise Edition, it's not one-time charge. It's a recurring charges per month basis. First 10 containers are free for your Docker Enterprise Edition. Correct? But Docker Community Edition is completely free for everyone. So some people ask me, is it good idea to use Docker Community Edition? Yes. I have designed and deployed many Docker-based container microservices farms, or you can say environments, and where we used to have a Docker community-based edition installed. Right. Now here for our webinar session, I simply install the Docker with the help of the command yum install Docker. That's it. But this is not a right way to do it. Correct. If I want to install, this is basically it's installing the Docker community based edition for you because that is free for everyone. But this is not the way to install it in a production or in your company environment. You have to go to the docker.io where you will be able to get step-by-step instruction, step-by-step repository information from where you will install the Docker community-based edition. If you want to go and play for your enterprise edition, Docker Enterprise Edition is free for 1 month. Okay, within 1 month, if you want to find out how Docker Enterprise Edition works, it is completely free for you, no problem. But after that, you need to start paying. So this is how I install it. So right now, the Docker is installed on my machine, no doubt about it. If I say service Docker status, currently the service is stop. I'm going to start the service. Currently my service is started. Right. So what I install actually, I installed Docker community based edition. Okay, that's fine. So let's see what is the version of the Docker. Okay. So there is a command called as Docker version. Press enter. Now one more interesting thing. It will confuse you a lot. Correct? I install Docker, but what is this client and server comes into the picture? What I told you whenever I install Docker, what I required Docker engine, which I run on the top of operating system. This is correct. This is the Docker engine. So if I see practically on my screen, this server, which is nothing but the reference of this Docker engine. I will talk about RKT because that is a one more technique. At the end of our session, I will talk about that. Correct. So this is the engine which I have installed, and it will refer practically as a server. Then what is this client? The client means whatever Docker command which I'm firing right now, this is nothing but the client. This client is actually take my command and give that particular command to my server for execution. So Docker is actually a client server architecture. Yes, both the components are running on the same machine. My client is installed on the same machine, server is also installed on the same machine, but whatever Docker command which I'm firing, this command is actually taking from client utility to my server, and my server will respond it back and give me that particular information. Correct? And what is server? I told you the server is nothing but Docker engine. He is actually doing all the job for me. Correct? Running the container, pulling the container, correct? Every activity will be done by that particular Docker engine. Correct? A Docker engine practically is what? Docker engine is nothing but a daemon process called as Docker. Correct? There is a process running on my machine, and that process name is called as Docker D. This is a daemon process. This daemon process, you can call it as Docker server, or you can call it as Docker engine, everything, whatever you want to do it, you can call it as anything. Correct? This background daemon process is actually doing the job for you. Client utility is something, for example, I will fire the command called as Docker info. From where I'm firing this command? I'm firing this command from client utility called as Docker. This utility sending this entire info command to this Docker D daemon, and whatever result which I'm getting on my screen, this is actually coming from that Docker D daemon, which is a engine. He's doing everything for me. Now, currently, the communication which is happening between client and server, that will be happen with the help of Unix socket. There is a Unix socket. If you know about the socket technique, okay, it is a inter-process communicator. You can see the inter-process communication could be done with the help of Unix socket. There is a socket. I will show you the name of the socket. Okay. This is the socket name. Correct. This socket is actually there in between your client and server. Whatever result which is coming from your server and displayed on your screen, and whatever command which you are firing, those communication which is happen between client and server with the help of this Unix socket. And some people ask me, that means, is it technically possible that my server is running on a different physical machine and my client utility is running on different physical machine? Will it be possible? Technically speaking, yes, it is possible. You can see my server is in USA and I'm sitting in India. I'm firing the command from India, but the execution will be done on the top of USSR. Yes, it is possible. Docker do have that capability. I can use the method called as API. I will open that particular API for TCP connection. Currently, by default, this particular API is closed. But if you want the same scenario like this, your client is installed on something else, you're executing the command from other machine, but the server will be somewhere else, the command should get executed on that server. Yes, it is technically possible. So API is available for Docker. That's the reason CI/CD is completely possible with the help of Docker, no doubt about it. Right? So understand, this is a client server process which is run. Okay, that is another beauty of the product called as Docker, no doubt about it. Correct. Now, one more interesting fact which I going to talk about it. Docker actually comes with a very beautiful solution. That solution is actually this: build, ship, and run. Okay. Docker concept was very clear. I will show you practically. Docker say you should build the image. Okay. You should ship the image. I will talk about this. And then you should run the image and create a container. If you run the image, it will become a container. Correct. So what is a build of image? I told you, you are going to create your own software images. Now there are multiple open source images is also available when we talk about ship concept, but Docker or container based technologies said you can build your own images because you want to run your microservice on the top. Correct. So what developers are going to do, I told you there is a concept called as Docker file. Okay, what developers will do, they will write a Docker file. Okay, now Docker file is nothing but step by step commands, you can say, or set of instructions are written in a such a way that the developer can take their own microservice code. So as a short form, I told you they will take their microservice code, they will take their necessary prerequisite, they will take everything in a configuration, and they will create a image from it. So creating an image with the help of a Docker file is a concept which developers are using, or you can say this is the best way to create your customized image for your microservice code. Now this concept is called as build image, which is possible in a Docker. Docker says either you can go for a Docker file, or there is a concept called as Docker commit. With the help of that, you can create your own image. Correct, but image will be created locally. Even I will write a Docker file over here on my local machine, but that image will be available locally. Correct. And I want to share that image to my some other colleagues which is also working on the same project. Then what I will do, how do I share the image? So there is a beautiful solution which is provided by the Docker, which is called as Docker Hub. Now this is a public solution as well as cloud-based repository solution. Cloud repository solution. So there are two options are available for this. Either you can purchase a private repository, or either you can go for a public repository. Obviously, the public repository is free. Correct. So that means I will create an image and I will upload this image to a repository. Now imagine guys, if I'm working for a company who is handling very crucial software codes, actually your source code, or it's a build, very important configuration information. So that is your proprietary image actually. I cannot take my proprietary image which is designed and developed by my developer, and I will upload that image onto the Docker Hub. Now, Docker Hub is a cloud repository solution offered by Docker company. So I can keep my image privately, no doubt about it. It's a secret, or there are a lot of securities is available, but still many organizations do not go for this kind of option. So what is the option there? There is an option that they can build their own repository inside the organization. Means within your organization, you can have your own repository where you can build your image, push that image over there and load it over there. If someone want to pull that image, they can do that, no problem. Correct? And run the image. That means someone can pull that image locally on their machine and they will run that particular image, no doubt about it. This is what we are going to do. So these are the three services which is offered by Docker company. Correct? I told you Docker is a company, Docker is the name of the product. So either way, if you talk about a Docker, that means you're talking about the product. So Docker offer you three type of services. Either you can build the image, either you can upload that image into the repository, or after that you can use Docker to run that particular image. Correct? So that is fine. So what I will do, I will try to go and give you a small example how it happens. Okay, don't worry about the commands which I'm firing. Okay, if you are getting familiar with this Docker command, you will also get very much known to this particular command. It's very simple command. Let's say if I want to search an image, correct? So I will say Docker search, and whatever I want to search, I will give the name of that particular image. Now CentOS is a free, or it's an open source operating system which I can download. Now where this particular search is going, now this entire command which I'm executing, it's executed from my client utility. It will go to my background process which is called as Docker server, and he will go to the Docker hub. Okay, the because all the open source, I told you there are two type of repositories are available. Either it's a private or either it's a public. So by default, I'm trying to search the image. That means my command will be going to the server. That is nothing but a Docker engine. That engine will directly go to that particular online repository which is managed and maintained by Docker Incorporation and try to pull the image from there. Correct? So if you could do that, you can see there are multiple images which you can see. But interesting thing is, if I go here something like this, there are something called as official. Okay, there are many other filters as also available, but you can see there is a concept called as official. 90% open source applications which I'm using or we are using, those all the applications you will get in the form of containerization, and Docker certified those images as a official images. Correct? So such kind of official images are also available. Now there one more interesting thing I'm going to talk about it, Docker info. Correct? Now here is a concept called as registry. Correct? You can see in this particular registry, that means this is the Docker hub link. Correct? So whatever search command which you want to search the image, by default my Docker engine going to this particular link to find out what is the image which is available over here. Correct? Now there are multiple ways that I can change this image or not, whether if I want to change it, that how I can change it. There are many ways we can configure this Docker engine as well. Correct? But you can see this. I want to pull this image from that repository. Correct? Now what I'm doing, once again, my client utility pulling the image from that particular hub and loading that image on my local machine. Correct? So if you see Docker images, you will see the image will be downloaded. Correct? Similarly, if I want to search or if I want to pull the image for Nginx, he will try to go to that same Docker hub link, try to search for that official images and will go for downloaded on your local machine. Correct? So understand, these all are images which is built by someone, which is certified by Docker and uploaded into the public repository that anybody can use it. Correct? Even if you want to use these images, you can use it and create your proprietary images, no doubt about that. Many people are using Java based images from here because there is a special image for Java is also available. These all images are certified. Okay, so if you are using it on a top of production side, it is always or highly recommended that you should only use either your proprietary image, or you should always use the official images from this repository. Do not try to use any other images which is not declared as a official images from this repository. That is a thing. So you can see that there is a concept that I can build the image, I can upload that image, I can pull that image. Now I will show you how to run it. Correct? So let's see, there are many commands, so we will discuss all this command, all this learning method in our full-time course, but here I will show you something like this interesting. If I want to see what are the images which I have, I will go for Docker images. Okay, I do have an image which is called as CentOS. Now this is image right now. This is just an image which I pull down from my Docker hub to my local machine. Correct? Now I want to run it. Docker run -dit. Enter. Correct? Now this image is actually become a container. So this is a different image. That is something, a box. I told you, you have created a box. Inside that box, I do have multiple things created. Correct? Now that box is now in a running format. So image will be in a running format, then it will become a container. Correct? So if you can go ahead, you can see Docker PS. You can see my currently this is my container ID because I took the copy of this particular image. Now this image, it is in a running form, and that running form is called as container. Now currently my container is running in the background because I done that. Correct? Now what is the foreground onground, we are not going to discuss that, but currently you can see my currently this particular container is running. If I want to run one more container, I will take the image, same image, and I will create one more container for it. Correct? So you can see these are the containers which I have created from the single images. I can start the container, stop the container, no doubt about it. Anything could be possible inside a container. So if I go inside a container, okay, I will go inside a container. Look at this prompt and look at this prompt where I am right now. I'm a root user, no doubt about that. But where I am, I'm inside the container. Can I see this? I will see there are two processes running inside the container. Now this, forget about this PS, but this is the bash is a by default process which is running where? It is not running my host machine. It is running inside that particular container. You can see that every process do have its own process ID. Correct? So you can see, technically speaking, now what you are saying practically, as per the container perspective, you have started a container, container is started, container got the ID. Am I able to go inside a container? Yes, I am able to go inside a container. Do I see any processes running inside a container? Yes, I can see that. Do I see the file system inside a container? Yes, I run the container called as CentOS. Is it the same file system look like normal operating system directory structure? Yes. So I got my entire directory structure over here. Do I got my own kernel? Yes. Correct. Imagine what I'm telling you. I'm inside a container. Every container do have its own file system. Yes, I can see that. Every container do have its own kernel version which I can display. Yes. Every container do have its own process ID information. Yes. Correct. Every container do have its own IP information. I don't know if config works or not. Yes. I got my own IP information over here. So I'm talking about a container. It's running. Every container do have its everything like that. Correct? But I will tell you a magic. Okay. If I say Docker PS, my containers are running. Okay. I told you there is a concept called as control groups. I'm going to see now. Do you see something like this? Do Control C. I will do something like, look at this container ID which will start with D7A. I say Docker PS. Do you see D7A? Correct. You can imagine whenever I run this particular container, correct, in my operating system level, now this is at OS level, what exactly happened? My request, the Docker run command which I have executed, correct? This run command I executed from a client utility. It will go to my Docker engine, correct, which is nothing but an abstraction layer on the top of my operating system. This is what we have discussed so far. What exactly he's done? My Docker engine talked to my operating system and told my operating system that I want to run the container. So my operating system say, okay, no problem. I will help you to run a process in an isolated format. And that isolated format process is nothing but it is your container. This is what I'm talking about. Now you can carefully check. I told you. Once again, I will show you. I will go inside a container. Do I see a bash process running inside my container? That is correct. I will come out of the container. Now I will go to the systemd cgls CPU grep. Okay. Do you see the process number? Now CGLS is nothing but control groups, and under the control groups I'm handling the CPU. I told you the CPU is controlled by control groups is a concept that how much CPU will be allocated for that specific process. So I got a concept that I got a same container over here. Inside a container there is this process number. Now what this process number refer? You see yes minus ELF. Now currently I am not inside a container. Here I am inside a container. Now this is an operating system. This is a host level information. So if I see PS minus ELF grep 10658. Correct. what is this? This is the process running, correct? So imagine what exactly we are going to understand by this. This is a process actually running or at a host level, correct? Your host, that means on which you are running this particular container. Technically speaking, the same process number is available on the host, correct? So container is nothing but a running process controlled by isolated features with the help of Linux kernel itself. Docker is the only one who can manage this all isolated process with his logic, correct? But technically speaking, do I see my containers running? Yes, I can see that. Every container do have its container ID, that's fine. Whatever running inside a container, actually it is running a process. If I see something is running inside my this particular container, yes, there is a bash process, but this bash process is not actually running inside a container. It is running on my host machine in a isolated format, correct? So if I see, I told you, once again I'm going to give you the idea. This is the process number for this bash, correct? This process is actually running on my host machine, which is related to that particular container. So technically speaking, this is a practical, this is how it works. Technically speaking, container is something which you are going to understand. It's an isolated process which will help you to run on a machine in a complete isolated way. So Docker help us to run all these processes in an isolated form, correct? So if I say Docker PS, it's a processes. This is a containers which I am running, no doubt about that. Now this container do have its own processes, own kernel, everything will be different. This container do have its own kernel, own processes, own network, own file system, everything will be completely different. Both will think that they are completely isolated on OS level, isolated on our resource level, but practically speaking, they are running on a single physical host. So this is a concept of containerization. So how this journey started? This journey was started in 1979. So if I think I will, how I can define this entire journey. Linux developer want to do the isolations between the processes and their resources. They are working from 1979 for this technique. In 2008, they got a very good breakthrough because they successfully developed such a kernel who can make that particular thing possible, correct? So every process will run everything whatever they required in an isolated format. I told you the concept is C group, namespace, and UFS support. So with the help of this technique, Linux developer develop a concept of LXs. Docker comes into the picture. They understand this concept properly. They created on the top of this LXC layer, they created their own layer who can manage entire process isolation, resource isolation, who can already there means that feature is already there inside a kernel, but Docker can handle it properly. Docker is very easy to manage, very easy to understand. Lot of capabilities are available. That means there is a concept called as Docker Compose. Okay. This is very important. Docker Swarm. Okay. Docker volumes is another concept. Config maps are another concept. So this Docker will help us to run every process in an isolated format. No problem about that. Docker also provide me that I can build the image whatever way I want. I will do that. I can put that image into the repository, whether it's a internal within the organization. I will be able to do that. No problem. So every solution is available to run my microservices. Every solution is available inside a container who will help me to run my entire microservices. Developers, what developers will do, they will create a Docker file, they will build the Docker image, and they will upload the Docker image to the internal report. Correct? Deployment team, what they will do, they will take that image and run it on the production or testing environment for further processing. Correct? Now there is one more question most of the people will ask me. Is it mean it is not going to work on any other operating system like Solaris, AIX, Windows? Technically speaking, in Windows, we do not have C groups, namespace, and union file support till Windows 8.1. Correct? And in Windows 2012, we do not have this kind of support available, direct support. I'm talking about kernel level support. Yes, there are workarounds are available. With the help of those workarounds, we will be able to use container technique. However, now in Windows 10 and Windows 2016, they do have this feature integrated inside their kernel. So it is much more easier if you are using container technique or especially Docker on the top of your particular Windows, if the Windows is Windows 10 or Windows 2016. Correct? So understand the first thing, the first benchmark is microservices. Run the microservices. We want a very flexible environment. Docker give me the very flexible environment. He will help me to build the image. He will help me to ship the image. He will help me to run the image the way it wants. And what is a container? Container is nothing but an isolated process which is running on your system, correct? And who will help us to make this particular container running in isolation format, correct? I hope that this will clarify many things in your mind. Believe me, this is the booming technique right now available inside your entire IT industry. Everybody is going for microservices and ultimately it will be going for containerization. Docker Community Edition is free. Most of the people are using that. So I will stop discussing about this. I think Sharanya asked me the question. I already pinged her in a private window as well. But I will ask you, yes, Pega systems currently I have not seen many of customers are using, but yes, in future, currently they do have everything tried and tested. Some of the container is also available on a hub repository as well. But yes, many of customers are trying to do for that. But in future, we will definitely have a complete standalone product or complete full-fledged product for a Pega system. Correct. Is anyone do have any question? You can go ahead and ask me the question in a chat window. We will help you to answer your questions. And as you can see,
I have a question.
yeah, go ahead.
Okay, so I mean, it clears a lot. I really appreciate it. The way you told. But I have like one example. I mean, I have, say, for example, I'm running a React application, right? So I want to
Mhm.
implement this practically, right? So currently I'm running my, say, React, Node.js, or Munstack application in my Mac. Okay. So if you want to test it out using the Docker or container concept, right? I want to install
Mhm.
this on a Docker container, and I want to run it multiple containers, right? So how do I do that? Is there any YouTube link or something, or some link where I can with your knowledge, whatever you have provided, if I want to test it out, my applications on containerization, is it easy to think, easy to do that, or it needs a lot of setup to do that?
Okay. Now I will clarify a few things for you. Okay. Let me ask you: are you a developer, or you means what kind of profession which you have? Then I
I'm a
will tell
developer.
you you're a developer.
Yeah.
Okay. Now, as a developer perspective, you should know how to write a Docker file. Maybe
Oh,
that
okay.
currently you're running all your application on a standalone physical machine. That could be a OS, or that could be a Mac OS, or whatever.
Correct. Correct.
If you said that I'm running the React application, Node.js application, or whatever application.
Yeah, it's on
Now
my
let's
Mac.
say I
Yeah.
want to, now let's say I want to convert it into the containerization.
Yeah.
Okay, that's fine. So what I need to create an image. And how do I create an image? I need to write down a step-by-step instruction in a Docker file concept. Docker file
Okay.
is a very simple concept. You need to write down how you are running your application on your physical machine. Same instruction set is available. There are multiple YouTube channels are also available who will help you to understand this concept, but majority of their examples are very simple. Now let's say you need to understand how Node.js application which you're running on your physical machine, and how do I do the same thing on a containerization.
Okay. Okay.
Correct.
So main thing is Docker
So
file, you're saying. Okay.
yes, you need to understand how to write a Docker file.
Got it. Got it.
Correct. So that is you need to focus on. If you understand how to write a Docker file, because developer required to understand this. If you are a developer,
Yeah.
100%.
So in your demo, you showed a CentOS, right? That thing that is kind of a image you install in a container, correct?
Yes. Now, in your case, what I required in what I required for Node.js application, I believe it's npm. Am I right?
Yeah. Yeah. NPM.
Okay. So you need to find out, is there any base image is available for your npm? I will show you. There might be some images are also available on a Docker Hub. Okay. So if I see sudo hyphen and say Docker search npm, you will get all the npm images already. That means I got a base image. On the top of that, somebody already done npm install. What I need to do, put your application, put it inside a container and run that application. That's it.
Oh, okay. That's neat. Okay.
So it's much, you don't need to install npm on your physical machine at all. Just have a container,
Oh,
run it.
wonderful.
Okay, that's fine. So this is a very beautiful technique for developer, believe me. It's very, very demanding
Hmm.
and very much beautifully implemented in many organizations. So if you go and try to switch the job, they will ask you as a developer, do you know how to write a Docker file? There is a very beautiful thing also available. In there are some IDE tools are available where the Docker file can also be automatically created.
Okay.
Just write your code. They will give you the step-by-step instruction how the Docker file could be written down. That is also beautiful things are
Oh,
also.
yeah. Yeah.
There are plugins available which you can search and you can go for it.
Okay.
Okay,
Okay.
now Johnny, how container scaling is done from command line? Now, Johnny, let me tell you, scaling means horizontal scaling, correct? So currently I'm running only one container at this moment of time. if I say Docker PS, you can see the scaling means currently I do have only 2 containers running. For example, let's say I do have 2 instances of my application running inside a container. Now, if I want to run one more application as the traffic is coming, I need to run one more run command to increase the number of containers. But this is for static standalone implementation. If you think, no, I don't want this thing to be manually happen, correct? I want this thing to be happen automatically based on the decision. I don't need to keep tracking my load balancer to check, correct? So there is
Auto
a technique
scaling.
called as, yeah, auto scaling methods are also available.
Yeah.
Correct? But that is not available in a standalone. You need to have a cluster based solution of it. Correct?
Okay.
One more, Docker Swarm is supporting auto scaling feature. Okay. Have you heard about Kubernetes?
Yes.
There is a concept called a horizontal pod autoscaler. Okay.
Yeah.
If you have a complete huge containerization environment, these are the techniques which we can use. That is possible, but not on a standalone machine. If you have a cluster-based solution, this is very good option which you can go for. Autoscaler is available. Correct. So Ravi, now Ravi said for a developer, what prerequisite required to start work on Docker in terms of hardware and software? To be honest, Ravi, I'm running my 2 containers right now on a machine which is simply 1 GB. So yeah, it's 1 GB. So technically speaking, the hardware requirement to run a container is very less, correct? You can, if you have a at least 8 GB minimum RAM machine, you will be able to run anything on the top of that particular thing. Software, you have to make sure that if you are using Windows, I told you, you should have at least Windows 10. If you are running a Mac OS, Mac compatible options are also available. Right? Third thing, if you are running a Linux based machine, that is absolutely fine. The Docker installation step-by-step guides are available on docker.io. Follow that instruction set. You should install the Docker engine on your machine. Once you install it, just follow how to write a Docker file. That will help you. So very minimum hardware, if you want to go to understand it, it's minimum hardware is requirement. Docker engine should be installed on your machine. That's it. You are good to go for it.
Yeah, thank you, Mangesh.
Yes, John, it is possible to run container in a virtual machine, but make sure that your virtual machine, at least you should have the Linux kernel version 3.0 onwards. You will be able to do that. No problem.
Okay.
Okay, if you have now kindly, I believe that everybody do have a feedback link. I will more appreciate that if you could go ahead and give me a feedback on that particular thing to understand what we can improve in a future sessions. Okay, and we have one more upcoming session which we are planning for, especially for Kubernetes. If someone is interested in order to understand the Kubernetes architecture, that is one more additional abstraction layer on the top of Docker containers, you should be able to understand what is Kubernetes. Now, before I close down, I told you about, I will talk about RKT. Now, this is one more technique which will be under development right now. It is developed by CoreOS. It is much more lighter than container, which is Docker currently, which we are using. This is one more container technique, which is not in the production right now. CoreOS is developing that particular technique, but they said even you don't require to run anything, any library. Currently, I told you your container should contain your application code, library, your all the necessary configuration. But RKT said you required only your application. It is much more lighter than the Docker. Maybe in 2021, they are going to launch their production ready version to run across the globe where people can try and test for it. Correct? Okay. Rama said, after every sprint, do you create a Docker image? Docker image is only for initial platform setup. Okay, now here I need to have much more elaboration, Rama. What exactly you want to say, actually? Your Docker images are platform independent.
Yeah, Mangesh, this is Rama. So I am from the background. Okay, I don't have much idea on microservices background. So basically, my question is the Docker image for only initial setup or after every sprint, right? Like you get the new application development, right? Do we have to create the Docker image and deploy in higher environments?
No. You have to create application for every new development. Okay. Now I will tell you one more interesting thing. Okay. Let's say my company is developing an application with version 1. Okay. So that application is currently running in a container format, no doubt. At the same time, parallelly, version 1.2, it's actually in the development process. So whatever new changes we are doing in version 1.2, I have to recreate that image of that particular version 1.2 one more time. So you can say every change in the development, I have to recreate the versions of the Docker images as well.
See, my question, see, no, like, see, version is not changed, okay? So I have started, initially I used the Docker image and installation is done, okay? So, you know, every organization using the Scrum and the sprints, right? So sprint 1 is completed now, okay? I want to deploy my code into higher environment. So do I need to prepare the Docker image using this new code also?
No.
So it is not for the, yeah.
It is not dependent on your environment at all. That's it. I told you my image is not going to talk about my underlying environment at all. He will directly going to talk about engine. If you have engine installed over there, I don't mind. I can run anywhere. Correct?
So yeah, see, like I have development period like 1 month, right? After that, what do you do? How do you get that same code in the higher environment using Docker container?
Simply run the Docker into that particular container. It's a very simple. Let's take an example. I have created a code, software code. Okay. I'm running that particular code from last few years. It is working absolutely fine. Correct? The environment which I'm using right now, let's say it's a complete Linux based environment which I'm using to run that particular code. I have not done any changes to my application at all. This is the same application code I'm running from last one. All of a sudden now my company said, no, I don't want to use this environment. I want to use the complete Windows environment right now. I want to change the complete platform of my particular application. Correct? Do I need to do recoding for that? Technically speaking, no. Just take the image and run it on your different platform. But what my platform is required? I required the new platform should have the Docker engine there. That's it. I already have the image of my application. My application image can talk with any Docker engine platform, whatever available in the world. Whether it's a Windows on the top of Docker platform, whether it's a Solaris on the top of Docker platform, it could be anything. My complete application is completely independent from my operating system. Correct? This is the beauty of the software. You can run it on your laptop, take it and put it on a Windows. That's fine. It is completely portable. No doubt about that.
Okay. I understood somewhat. Like one more question. So do we also include DB scripts also part of the container, or it is independent? So you mentioned Docker file is used a container, right? Like it is set of command. So do we
Mhm.
include DB scripts also there?
If you required that DB script to be there while you're running the container, for example, yes, in some cases, I need to put some configuration files, some script inside a container because I know that whenever I run this container, this script should run. If I want to run those script while running the container, then yes, I need to have that. But people will never do that. I will tell you that also. Okay, there is a concept called as Docker volume. Okay, normally
Okay.
I will put the script outside somewhere on my host machine, but I will ask my container that whenever you run, take this script and then only you can run those particular container. That is technically possible. So normally these containers are non-persistent. That means the data will never keep inside. So normally we will never put the scripts over there. We will put the script outside, but we will make sure that whenever the Docker runs, it will take the usage of those script as a volume and then he will execute. That is possible. Yes, Ravi, go ahead.
Sorry, Mangesh, I know we are running out of the time, but just but how actually, as of now, the client is not using any that this Docker concept. How we can going to convince them to the client, because we are using. I know as a developer, I understood that Docker is as a yes, is a container, and it will be a tool like we can run to the deploy the application by taking into package. But how I can as a developer I can convince to the client to use these things actually.
Okay. Now there are multiple ways to handle this kind of issues, Ravi. Actually, I don't know from which domain perspective you're talking about, but I will tell you my experience. I'm
Okay,
working for a company called as Mahindra Combiva.
okay,
They do have multiple applications running on a monolithic way, actually. Correct.
yeah,
First of all, when they contacted me in order to understand, because they were having some problems, you need to find out what is the painful task which these people are doing for that applications, to be honest. So they are
okay,
running a very simple marketing application in a monolithic style. Now, currently, they want to scale up and they couldn't do it because that application was designed by a third party company. Okay, and
yeah,
now they want to put some new features on the top of it and they couldn't do it because that was a monolithic application. I
correct,
said, now this application is not work for you, cannot do anything. If you want to do this, you have to redesign this application and split it in a microservices way. So whenever you got any other application feature you want to deploy in your application, it's a plug and play. That time I told them that if you want to run a microservices, use containerization. It's a beautiful technique. Tell them about scalability, fault tolerance, high availability, how it will be easy to manage it. Correct?
yeah,
You need to first find out what is a pain point for those particular application and how you can resolve these all pain points with the help of containerization. If you try to convince in this particular format, then it could be very much easy. Otherwise, there are many applications like they have some application which is still running in C++. How I
correct,
can convert it into the container? I said, first of all, find out the same logic. Can I write it down in the Python? They said, yes, it could be. Then first find out whether is there any substitute technologies available or not. If it is available, give me the Python code. I will make sure that I will convert it into the container. I will write a Docker file for you. No problem. Correct.
okay,
So
yeah,
find out if you want to convince as a developer, first of all, find out what are the problem areas which you have and how you can resolve those problems with the help of this technique.
Okay.
If you're 100% sure, yes, I will be able to have all the problems will be resolved, and plus I will be able to manage my application very smoothly with the help of these techniques, it could be good, no doubt about it. Correct. So there are
Perfect.
multiple way to convince the customer, no doubt about that. But first of all, understand containerization properly, understand Docker properly. Once you understand Docker properly, the next step is to understand Kubernetes, because you will never get Docker in a standalone. Either you will deal with Docker Swarm or Kubernetes. Be
Okay.
careful about this,
Oh,
because but Kubernetes, if you want to learn Kubernetes, you should have the Docker understanding first of all clear, because many companies want to deploy their microservices in a such a way that they don't want to work on microservices how they are deploying. So there are orchestration tool they want to understand, and that orchestration tool is Kubernetes. Don't worry, we will be arranging the session on the Kubernetes where you will get an idea what kind of tool that is. Okay.
okay. Okay, that's perfect. That was, but thing is it really is because we are running in a cloud actually, that still it will be easy to set up if even if you identify the pain points, then if you
Mhm.
convince to the client and then we are come to the conclusion, yes, we are going to start this Docker and Kubernetes combination. Is it really easy how you are showing today's session like that, or it will be again different in cloud when you
Okay.
compare with on-premises?
Currently, I'm running my container on the cloud on AWS machine. Okay? I will tell
Okay.
you, there is one more interesting fact. Currently, what I did, I took a EC2 instance, I installed the Docker on the top of, and I done whatever things I required. Now this is only EC2 instance which I'm running. But there is one more beautiful thing is available on all cloud, that there is a container as a managed service is available. There is a service called as Amazon Container Services. So even if I directly use the managed service from Amazon, I really don't need to do anything. Just need to put my application code over there. That's it. Behind the scene, they will build a machine, they will install the Docker, and they will run the container finished. So Amazon also providing the container services as a cloud-based solution. Azure is also providing that. Google is also providing that. So that will be considered as a managed services. But if you don't want your code to be or your image to be managed by someone else, you can take the EC2 instance the same way which I did, install the Docker, create your image file of your application, run the image file and test it. No problem. No doubt about that. You can do it.
Oh, super, super. Yeah. Thank you,
Okay.
Mangesh. Thank you very much.
Thank you all of you guys. Thank you for your time and patience. Okay. If you have any doubts, you can just mail it to me, and you can mail it to the PITC. We will definitely get back to you. Okay.
Yes,
Yeah,
yes. Thank you,
perfect.
everyone.
Okay. Bye bye. Take care.
Yeah.
Take
Thank you.
care. Bye.
Bye.